Hello everyone, welcome back to MAC1105. Last time we introduced basic function and we talked about the sketch, the domain, and range of that. We also know the question of evaluation. It means that we want to find output given a certain input. That type of question, we can do it by plugging the value, the input into the function, and whatever you have after you plug it in, it could be the output. Okay, it could be one of the value of the y of the range. Okay. Now, so you see that if you put the value input as a number, the output will be also a number. And a number we can add or subtract. So it means that maybe the function we can add or subtract, we can multiply or divide. Okay, so in this section is section 2.8. Let's see how we're gonna do operation on function. I mean how we're gonna add or subtract, multiply, divide function. And let's see what if the input is not just a value, what if it is just a whole function, or what if it is a whole expression. How we gonna do that? Okay, so let's get started. Section 2.8. Well, it depends on each textbook, so I just put over here the topic over here is just a operational function. Okay, so I put over here operation. Okay, operation on function. Let me see. Function and a composition of function. Composition of function. So on the first part, we will be talking about operation on function first. Then on the second Roman, let's talk about composition of function. How we're gonna evaluate a function at a certain function. Okay, so the first part, operation on function. Oops. Okay, operation of function. Because the output or the input of function is just a value, it means that we can add or subtract a function together, and indeed we can do so. What if given what if we have two functions like given? Oops, I'm sorry. I think I did wrong. Given two function f of x and g of x. Okay, and what if I go ahead and add them together or subtract them together, we can obtain another new function called the sum of two functions. Okay, so this is the sum of two functions will be the function of the sum. Okay, and how about multiplication? Yeah, we can do that too. What do you have? F of x multiplied by g of x. Then we have the function of the product. So we have f times g of x. And if I have f of x divided by g of x, then we have f over g of x. Of course, in this case, because g of x is in the denominator, so of course g of x must be different from 0. Well, if you notice, you see this is kind of nothing but college algebra. In college algebra course, we already talked about this. But in this course, we do just nothing but a review. We probably do more example that more complicated. Okay. Now let me give you example. So how about the domain and range? Of course, the domain and range of this one will be sometimes will be similar to f, sometimes will be similar to g, and sometimes it's totally a new one. Okay, I don't know how much your professor in the previous course in college algebra, I don't know if he or she talk about domain a lot in your course or not, but finding domain is kind of tough to some student. And as I said, it depends, let alone finding the domain of the sum or the domain of the product. So I may give you just a couple examples of finding domain of the sum or the product or even the quotient. Then most of the time we're gonna learn how to evaluate a function at certain value, or we evaluate a function at certain algebra expression. Okay, so let me give you a basic example first. What if I have I give you two functions like this. F of x is the basic one. Okay, for example, x plus 1 and g of x is 3x minus 2, something like that. Now I want you to find f of g of x. Okay, fine. Let me see. Fine. Then on part B, I want you to evaluate that sum, okay, function of the sum right here at 1. Okay, let's see how we do this. So answer. Part A will be easy because we have you want to find the function of the sum. So the function of the sum according to the definition will be the sum of two functions. So we basically you just add them up. Okay, but if you do subtraction, if you do the difference, then of course you gotta put a minus here and you gotta put parentheses. So this is give you 4x minus 1. And in order to find part B, which is you want to evaluate at 1, so all you have to do, you just plug 1 into this. So you have 4 times 1 minus 1 will be 3. Here you go. So that is the output. Now, what if for part C? What if for part C they ask you to find the domain of function sum, like this one is a little bit tougher, depend on what function you add or subtract. So if you notice, we know that domain of f of x is the line. This is a line, so the domain is the domain here is from negative infinity to positive. Okay, but the range here, the domain, I'm sorry, but the domain of g of x is also from negative infinity to positive infinity because both of them is linear function. Okay, that's why when you add them up, the linear function and a linear function, you see that the sum of two functions here, it is also linear. So you see this one right here is also linear. So the domain is your sin f plus g of x is also linear. So on part C, the domain of f of g of x is also negative infinity to positive infinity. Okay, so the domain of the sum of the difference will be the domain of the domain of each of them. But this still depends. So it depends because you have to find the domain of the sum right here. It is not always like that. What if you have over here is quadratic and over here is a radical? Then of course the domain will be different. It's not from negative infinity to positive infinity. In that case, you gotta investigate the domain of the sum after you add it, or the domain of the subtraction of the function after you subtract it. You know. Now let me give you another one. For example, I have this. Example 2. What if I give you two different functions? Okay, they are given. What if the first function is the absolute? Okay, and the second function is a radical. Okay, now I'm asking you the same thing, but in this case I'm asking you to find f times g, the product. Okay, and I ask you to evaluate. Okay, at -1. Then finally, I ask you to find a domain of f times g of I, because this is a new function. You have a function, you multiply by another function, which is to give you a new function. Okay, so let's see how we do this answer. Alright, so part A kind of easy. So you have multiply them up. So you just put this, multiply by that. There's some multiplication sign right here. Okay, that's part A. Part B, you choose evaluate. And it's pretty easy also, you just plug them in. So this is give you 0. So the answer is 0. Okay, answer is 0. Alright, but part C is kind of hard. Alright, so if you notice the domain of f of x, so I'm gonna call it D1. It's the domain of this, and this is absolute. So the domain here is this. You know, all the domain of absolute function is negative infinity to positive infinity. But for D2, in order to find domain, you're gonna set the radical, the radicand greater than 0. So this is greater than -1. So the domain D2 will go from -1 to positive infinity. So right over here again, I want to mention one more time that I don't know how much your professor went through the domain section. Maybe some of professor went to that really deeply. Some professor they just do a kind of superfluously, you know, just an overview or some kind of for you to know only. But I mean, over here in this example, I kind of cover from the easy to the hard one to the some low level to a little bit higher, so that you know that, because this, in order to find the domain of the radical, maybe some of you forgot, but you just need to set up a greater than equal to 0, and you see the domain of this. And now you have the domain of this, you have the domain of that. So the domain, the domain D3, which is the domain of this. So this domain of this, I call it D3. You have to look at this one, and you have to look at this one, D1 and D2. So last time you see the problem that we have the domain the same, so of course when you add them up, they're linear. But you see when you add them up over here, it's kind of absolute and radical at the same time. Okay, so the domain, just think about this is the domain of this. You're gonna find intersection. So the domain D3, which is the domain of the product sum, the product function right here, f times g, will be this, because you find the intersection. So the domain will be -1 to positive infinity. Okay. Well, you find intersection. Okay, you find intersection. So that's how it is. Okay, that's how you find the domain of the product. Now, what if it's the quotient? What if I give you two functions like that? What if the first function is f of x is again give you 1 over x minus 1, and the second one, g of x, give you another function is 2 over x plus 2. I'm asking you the same thing. First thing, I want you to find f over g of x. Then on part B, I want you to evaluate f over g of x at negative 3. And finally, I'm asking you to find D3, which is domain of f over g of x. Okay, I want you to find that. Okay. So what's about the first part? Should be simple. So this is the quotient between two functions. So be this over this, and you do keep chain flip. So the answer will be x plus 2 over 2 x minus 1. Okay. Then on part B, you just evaluate it at negative 3. So you plug negative 3 in. Plug negative 3 here. So negative 3 minus 1, negative 4. It's negative 1, 2, negative 4. So I'll give you 1/8 as the output. Now the domain. Alright. So first of all, we need to find the domain of this. So the domain of this, so the function is not defined at 1. So the domain will be, so I'm going to call the D1 will be negative infinity to negative 1. Or to 1, I'm sorry. It's not defined at 1 because 1 minus 1 is 0 over here. You cannot divide by 0. Okay. Then you find the domain of the second one. You cannot define at negative 2. Okay. Now, so because you cannot define at 1, you cannot define negative 2. Okay. Now you, in order to find D3, which is the domain of this, you see the domain of this? At negative 2 is still defined. So the domain, of D3, which is, you have to look at this domain, the domain of this one. So it will be at 1 it's not defined. So the domain, because 1 minus 1 is 0, so it's not defined at 0. It's in the denominator here. Okay. So the domain of the quotient will be negative to 1 union 1 to positive. The reason I did not pick negative 2 because at negative 2 it still work. It does not work here, but it still work here because negative 2, negative 1, negative 3, negative 3 times 2 and negative 6, everything is good. But at 1 it's not working. Okay, so in order to find the domain of the quotient or the domain of the product of the two functions, you have to look at this. Okay, and the good thing about this is that it's still the same type of function. Like in the last example, it's different type, so you have to consider really carefully. Okay, really carefully. Okay, you gotta look at this one, look at this one, and for this is example 2 right here, you gotta find intersection, but this one you don't have it. You just need to look at this one. Okay. Alright, so that is how you do operation on a function. You just basically you add them up, you subtract and you multiply, and you divide evaluation. All you have to do is just go ahead and plug them in. Okay, and let's see, I can give you something. Let's see, I can give you another one, just in case like you see something like this in your homework. Well, I think that's pretty good enough. It still depends on the function. I'm gonna give you another one, but this is for you. Just try to practice this one, okay? So I'm not gonna finish this example 4, but I give you that so that you see that you can practice, and you can ask me if you have any question. So what if I have this, and the first function is the quadratic, okay? Then I give you another one. And the second one is not quadratic. The second one is linear. Okay. Okay. Now I'm asking you the same. First of all, I want you to find. Now I want you to find the sum. Maybe just the difference. I want you to find this f minus g of x. Then I want you to evaluate f minus g of x at -1. Okay, and at the end, let's see the phi domain of f minus g of x. Let's see you can do this or not. Okay, in interval notation, of course. In interval notation. Okay. All right, let's go ahead. Let's try that one. And if you have a question, just send me the message. Okay. Now, on the second part of our lecture, let's just see what is happening if we have a function as the input. But before doing that, what is happening to the function if the input is an expression? So I'm going to divide the second Roman of our lecture. So this is into two parts. So this is second part. The second part we talk about a composition of function. Okay, so I'm going to divide this part into two parts. Okay, so the first part which is what happening to the function if we have the input as an expression. And during the process, I will be introducing a concept called difference of quotient. Okay, so let's see. So in the first part, let's talk about difference of quotient. So we already know the quotient means division. Okay, difference of quotient. Now, let's start with the example right away. Or let me say, I think we should start with the formula. Okay, so the difference of quotient formula is f. So let me write it here. F x plus h minus f of x over h. Now you see over here the input is an expression, right? And this is the original function itself. So the input is an expression. So it means that we're gonna put this expression into the function. Then we can find difference of quotient easily. Okay, and not just this expression. You know, we can put any expression into the function, but this specific expression will give us the difference of quotient. Now let's get started with the first example. What if I give you a function like this? What if I give you f of x equal to x plus 2, and I want you to find difference of quotient. Difference of quotient. Okay, so let's see how we do that. So last time when we do evaluation, we just go ahead and plug it in, right? So this is last time. So I changed the color a little bit. I just feel like this is too bright to me. So I just go back to normal. This is, I don't know which color you like. You know, you tell me, okay? But I think this one is better. This one, maybe some of you like this too, but I think I like this color because it's easier for the eye. This is too bright. So when you evaluate, you just plug them in. Okay, we evaluate the function, you just plug it in. But now we evaluate the function at x plus h. It means that we're gonna plug in to the function x plus h. So you're gonna replace the x over here with x plus h. We will have x plus h, plug the whole thing here, plus 2. Okay. Then we're gonna set up the ratio. And then we can set up the ratio x plus h plus 2, which is this, minus f of x. But f of x is this, so we gotta put in parentheses over h. Alright, distribute the minus in, minus h minus 2 over h. So you see that this cancel, so you have h over h, give you 1. And there you go, that's this difference of quotient. Okay, I mean, difference of quotient is not hard, just to evaluate a function at this specific algebraic expression. Of course, some function is harder. Depends on the function. If the function is harder, then the difference of quotient will be harder. What if I give you the function which is quadratic? Something like that. And I want you to find difference of quotient. Difference of quotient. Okay. And of course, you're gonna do the same. So you calculate f of x plus h. Plug it in. Okay, so plug it in square plus 3 x plus h. And you square that, you expand them out. Okay, and you multiply 3 in, and you combine like term. Anything we can combine like term? No, we just leave it like that. Okay, we just leave it like that because there's nothing to combine. Okay, then our difference of quotient will be what? So difference of quotient will be x squared plus 2 xh plus h squared plus 3x plus 3h minus f of x. It means minus this. What happened? Okay. Minus this over h. Alright, now you just distribute them in. X squared plus 2xh plus h squared plus 3x 3h minus x squared minus 3x. Alright, it's cancel. X squared is cancel over h. So what you have left is h squared plus 2xh plus 3h over h. Alright, and now you factor the h out, so you have h plus 2x plus 3 over h. Then you cancel. There you go. This is your, what you have left is your difference of quotient. You gotta simplify everything to the end. Okay? So evaluate the function at a certain specific expression. It's not really that bad. Just again, just go ahead and plug everything in. Okay. And now we already know how to do with the expression. And let's see what happens if we do it with a whole function. So if you consider a function as an input, okay, then you see that if you let's go back to it. If you consider a function as an expression, you see that at the end you have a new algebraic expression. But if you consider a function as an input of another function, then at the end we can create a new function. That function is called composition of function, composite function. So part B. So this is part 1. So part B, part 2, composite function. We can create a whole function called composite function. Okay. Alright. Given two function, f of x. Okay. Two function, f of x and g of x. Okay. Now, if g of x is the input of f of x, okay, if g of x is input of f of x, then we can create a new function called composite function. It is notated as f composed to g, okay, or you can write it as f o g, as composed to g of x. So there's two different ways of writing. So this is a new function, it's composite function. This is a new function. This is the same thing, but it's two different notation. We can write f of g of x or f composed to g of x. Okay, so we can compose two functions to each other, or we can also compose the function to itself. It gives you a new function. While the domain, of course, will be the same or different, depends on what function you compose. Now let me give you the first example. And we can also evaluate the composite function at certain value if you want to. Given two function, what if I give you 2x plus 1 and g of x is x minus 2. So I have two linear functions like this, and I want you to find f composed to g, okay, g composed to f. See, I can compose to one another, or I can compose f to f if I want, or g to g if I want. It depends on question which one they want you to do. And when you compose like this, the answer of course will be the function. Okay, answer. Now let's do f of g first. F of g, f composed to g. It means g, you see, g is input of f. G is input of f. G is input of f. It means that you're gonna plug g into the x of the f. You always go backward like this. Okay, g go into f. So g go into f. You will have 2. Yeah, 2 is still there. And you throw this away, and you replace that with f. Would you replace that with g, which is x minus 2 plus 1. So you have 2x minus 4 plus 1, which is 2x minus 3. Now what do you have? After you compose f to g, you see the function is still linear, but it's not always like that. So it depends on what function you have. And if you do g to g, g to f, it means f you're gonna plug into the g. You always go backward. F into the g, so you have 2x plus 1, 2x plus 1 minus 2. So you have 2x minus 1. Okay, and you can also compose f to f. F to f. I'm gonna let you do g to g. Okay, f to f. So you're gonna do f into itself. Okay, so you have 2x plus 1 plus 1. So you have 4x plus 2 plus 1, which is 4x plus 3. So every time you compose, you see they give you different function, and you see that the domain will be the same. The reason is that the original two function here is linear, so the domain goes negative infinity to positive infinity. But when you compose, of course, it gives you linear. But if one of them is quadratic, you have to be careful. The domain will be different. The domain, it depends on after you compose. Okay, all right. And you can also evaluate. What if I want to evaluate f composed to g at 1? Then you just plug 1 in here. So you have 2, 1 minus 3, give you negative 1. See, that's it. Okay, that's how you do compose between two functions. Of course, again, just some function is harder than the other. For example, in this case, what if I give you the first function is something like this, and the second one is 3 over x, and I want to find g composed to f. Okay, that's part A. And part E, I want you to evaluate g composed to f at 2. Okay, let's see how we do this. Easy, you follow the same way. So g composed to f, you mean you plug f into the g, go backward. Okay, so you add f into the g, so this into this, so you're gonna have g of f x will be f into the g, so this go into here, this go in here, so you can have 3 over 1 over x minus 1. So keep chain flip, you're gonna have x minus 1 over 3. Okay, so look at that. If you have a rational function you compose, at the end you have linear. So the domain over here will be linear, negative infinity to positive infinity. It's not always the domain of the original one. Okay, so the domain over here is different, domain over here is different, but at the end the domain over here is not the same as one of this. The domain over here will be negative infinity to positive infinity because it's a linear function. Okay, because of linear function. This is linear. It's not rational anymore. We're gonna talk more about rational function later on. But this is a quick recall of the rational function we already learned in college algebra. And for part B, evaluation will be easy. G of f at 2, so plug 2 in. 2 in here. So 2 minus 1 over 3, 1/3. There you go. That's it. That quick. Okay. But on the next example, what if they give you the graph? Okay, what if they give you the graph? What if they give you like this? What if I have the graph like this? Okay, I have the graph like this, and on this graph I have 2 functions. So let me use this one. Let's say that the first one is something like this. Okay, and over here, and this is 2, and this is 3. And I say this is f function. Okay, and I have another one. Let's say another one is something like this. So this is 3 right here. This one like that. Okay, this is g of x. Okay. Okay. Let's see. Let me redraw it. Okay. Now the question is, find g of f at 2. Alright, now I have a function like this. I have the graph. So it means that we gotta find f of 2 first. Alright, we gotta find f of 2. So f of 2, by observation, we know f of 2 gives you 3. Then we find g of 3. G of 3 gives you 1. So this is 1. G of 3 gives you 1. So g of f of 2 give you 1. There you go. That's how you look at the graph. We just go again. You always go from left to right. You always go from left to right. Okay. You always go from. I mean, you find f of 2 and whatever it is. So this will be the output. The output of f will be the input of g. Okay. Output of f So I'm gonna put over here output of F is input of G. Output of F is input of G. And here you go, you're gonna get the output of G or F. And you can apply the same thing for all of them. Okay. So I think I'm gonna stop this lecture 2.8 over here. If you have any question, please let me know. Again, I'm really sorry for changing the color. I don't know which one you like, but if you like this one, you can let me know. But I think I'm gonna stick to this one. It's much better. Okay, I'll be seeing you next time. Bye bye for the new video.